PMI and then injected into a CAM planning software like Step NC that you saw upstairs. And from that Step NC, we can generate process plans and do that via AP 238, and then use that in the process of simulating or simulated or execution of those process plans. In addition, what we can do is extract the stage models from that process and pass those downstream so that we can get in-process validation of the measurement of those models. We've done that through a conversion mechanism step to extended ASIS, and then extended ASIS into the MyCAT planner. You'll see that here in just a few minutes. And then that in the MyCAT planner, we pass that through to simulation and execution in the metrology area. And after that simulation execution, we can analyze that data and then produce a result of the measurement activity in QIF format in the form of QIF results. One significant requirement for this is the notion that we need traceability. We need the ability to trace PMI entities, a characteristic, if you will, through the MBE process. This is a regulatory requirement. We need to be able to create a link between the characteristics that are input and the results data that are the output. And we need to do this. We need to have a stable, permanent ID in order to do it. We could use the native CAD IDs, and there is an activity among the ISO team to look at permanent entity IDs for certain purposes. But in this research, we decided to use the Part 21, Edition 3 anchor section and insert the UUIDs into that section of the STEP data. These formal UUIDs are stable, they're uniform, and they are permanent. What we did is anytime a application created a piece of PMI, we generated a UUID along with that PMI element. And then carried those UUIDs down through the process. If a downstream application added another element, PMI element, we created another UUID for that application. And by doing that, we were able to demonstrate linking that data all the way up and down the process chain. Now, you may have heard upstairs the notion of validation of the simulation, using the simulation as a mechanism to validate the manufacturing process, validate the metrology process. There's also validation in the context of just transforming the data from one format to another. Traditional drawing exchange, this was very transparent. It's a manual checking process, but when we begin talking about MBE and the transformation of the data in the context of a model-based enterprise, the process is not transparent. It's a black box. And because of that, we need to have the notion of automatic validation. What I'm going to show you here is that portion of the generic diagram that we saw earlier, looking specifically at what elements we used upstairs, Step NC, and the MyCAT planner down here, and you see the red indication of the UUIDs generated by each of the applications, and then ultimately bringing those back out through QIF results. A little later, I'll talk about how we might capture and reuse the QIF results after the fact. In terms of validation, again, I apologize for the washed out nature of the slide, but in this particular instance, in the left-hand side, what you see is the upstream source step data. In the right-hand side, you see the downstream extended ASIS data, And in the lower left and lower right boxes, you see the data structure that represent a particular piece of PMI. In this particular case, it was a linear dimension with bidirectional tolerances. And in this case, they match up correctly. But because this is a black box, what we also need to do is be able to find and identify and correct issues with the transformation of the data downstream where that data is incomplete. Here you see an example of a datum target, and as you can see in the right-hand picture, the associated geometry is missing from the data. Here, let me back up one. I'll let it go. So here you see the actual in-process model in step NC. If you look very closely at the highlighted piece of GD&T data, remember this data has originally come from CAD via step 242, and then we can add additional annotation that's pertinent to the manufacturing process. But you'll notice the identified piece of GD&T includes that UUID that I just described that permanently identifies this piece of data for downstream use. That's interesting. There we go. There's the last one. Okay. And downstream from the manufacturing planning process is in the MyCAD planning process. And here again, we're able to pass that PMI data content through step AP242 and through extended ASIS into the MyCAD planner, complete data structure, semantic information about the piece of PMI. So at this point, I don't know why it's bouncing around. I apologize. Go back. There we go. At this point, what I'm going to do is turn the floor over to Brian Cox from Minatoyo. He's going to actually show you a demonstration of this live on MyCAD.
My name is Brian Cox. I'm an applications engineer out of the Renton